welcome back to our lecture series on the material science and metallurgy subject. In today's lecture, we will talk about next set of ferrous alloys, that is cast irons. In the last class, we have discussed ferrous alloys that are steels. So at first, we have discussed steels, plain carbon steels we have discussed, under which low, medium and high carbon steels we have discussed. Then it is followed by alloy steels, in which we have seen stainless steel as well as tool steels. These are the two cases we have seen. In today's presentation, we will talk about cast irons, the basic introduction about the cast iron. Then its classification we will talk about. Then in particular, we will start with grey cast iron, its composition, microstructure, properties, limitations, applications we will discuss, and towards the end we will summarize and discuss the key takeaways from the lecture. So why are we alloying? If you recall, why are we alloying? Basically, alloying is a combination of two or more materials which has been intended to enhance the properties. These properties include mechanical, thermal, certain physical properties, or any of these categories. In particular, we will look at the enhancement in the strength, its hardness, corrosion resistance, and wear resistance. If you see the cast irons is a family of iron carbon alloys with carbon content which is typically ranging from 2 to 4% in practical scenario. But as per the iron carbon phase diagram, it is up to 2.14 weight percentage of the carbon. So we categorize them as the steels. Then from there on, it is the cast irons 2.14 to 6.67 weight percentage of carbon. We termed it as cast iron. So if you look at iron carbon phase diagram, we have it on the x-axis composition, weight percentage of the carbon. Then on the right side we have temperature temperature in degree centigrade. So up to 2.14, up to this category, so we call it as steels. From here to here we call it as steels, iron carbon alloys. Then from here to until the maximum solubility of the carbon, that is 6.67 weight percentage of carbon in the iron, we call this category as the cast irons. So now we will focus about this cast irons. So in the cast iron, the important reactions, if you recall, the important reactions, invariant reaction that it takes place at 4.3 weight percentage of carbon. So at 4.3 weight percentage of carbon, this is the point. At 1147 degrees centigrade and 4.3 weight percentage of carbon, we see this reaction, that is a eutectic reaction. So this is called eutectic reaction. What happens in the eutectic reaction? It is the liquid molten iron. So that is a molten iron that is getting transformed into two solids, that is solid 1 and solid 2, that is gamma austenite, gamma iron, plus this is second one is the cementite, Fe3C. Sorry. So this is Fe3C, cementite. So this is the point. If it is been cooling, okay. So this is a liquid iron, so molten iron, so which is getting transformed at this point 1147 degrees centigrade. It is transforming into two solids. One is a gamma austenite, iron in the austenitic form, gamma austenite. Then it is the cementite, gamma austenite plus cementite. Gamma austenite, which is having a FCC crystal structure, whereas cementite is basically ceramic material. It's a carbide cementite. It's a very hard material. So this is a reaction that it is taking place. This reaction is called eutectic reaction. One solid is transformed into two solids upon the cooling. So up to this, from 2.1 to 4.3, we call these as the hypoeutectic cast irons. This is the region hypoeutectic, and from here to here, if you recall, we have discussed that it is hypereutectic. So most of the practical cases, we will be having cast irons mostly, that is a hypoeutectic cast irons. We talk about this hypoeutectic cast irons, which is having a range of carbon from 2.14 to up to 4.3 percentage of carbon will be present in the iron. So generally, cast irons are class of ferrous alloys. Again, this is iron as the primary metal, ferrous alloys, with the carbon content that is ranging, that is above 2.14 weight percentage of carbon, and until the maximum dissolvability of carbon in the iron, that is 6.7 weight percentage of carbon. So in practice, however, most cast irons contains between 3 to 4.5 or 2 to 4. It could be 2 to 4.5, or in some cases, more majority it is ranges from 3 to 4.5 weight percentage of carbon. And in addition to that, we will be having other alloying elements. Certain other alloying elements also will be present, and which we will discuss in the in couple of minutes. And cementite, as we have discussed, cementite is a metastable compound. So Fe3C, iron carbide, is called cementite. Cementite is a metastable compound which is not stable at room temperature. So it is a metastable compound. Under certain circumstances, it can be made into dissociate, or it can be decomposed. Under certain conditions, it can be decomposed into two. One is ferrite, that is alpha ferrite, and it is graphite. So this reaction looks like this. Iron Fe3C, iron carbide, can be converted into alpha ferrite and carbon graphite, and which is very important reaction in terms of um, cast irons. So what are these circumstances where the cementite will be breaking? What elements need to be added, which we will see in short time. So why are these cast irons are important? So what are its engineering applications, where it stands, and what are its mechanical properties and thermal properties and general physical properties? If you look at it, why these cast irons are important? Cast irons offers excellent castability. So they offer excellent castability, so ability to cast the material, which is offering, why it is having excellent castability, because of their low melting temperatures, melting points, and its good fluidity, so good flowing properties. Because of their good flowing characteristics as well as the low melting points, they offer excellent castabilities. Then they also have very high wear resistance. From where this wear resistance is coming? That is from the iron carbide, the presence of iron carbide, which offers a very high hardness along with the wear resistance, high wear resistance. Especially the white and alloyed cast irons are having the highest wear resistance among the other cast irons. Then it also offers good vibration damping. Damping vibrations can be controlled because of their because it absorbs the energy that is released through the mechanical vibrations, and so these are the likely material for engine block components. These are the these are of first choice because of their good vibration damping characteristics. It can isolate or it can absorb the mechanical vibrations, and it is very critical in the shop floor, mechanical shop floor, because each machine will be vibrating during its operation, which need to be isolated, and that is very much possible with the foundation or the found the bottom materials. So which is here in this case, it has been used by cast irons, and it is a cost-effective material when compared to steels for larger and complex structures. So this is also because of this reason is also they find very good engineering applications. Then if you look at the classification is primarily based on the microstructure. Based on the microstructure in the cast irons, they are being classified into uh, four categories primarily. So first one is called as gray cast iron, then white cast iron, the ductile cast iron, and malleable cast iron. So based on the microstructure, these cast irons are classified into four. That is gray cast iron, white cast iron, ductile cast iron, and malleable cast iron. And we start discussing about this gray cast iron. So first we will look at its composition. This gray cast iron consists of carbon. All the cast irons will be having the carbon, which is in this gray cast iron. Carbon is ranging from 2.5 to 4 weight percentage. In addition to that, other alloying element, that is silicon. Silicon is varied between 1 to 3 percentage. So silicon is being added to the it is added to the iron here because it promotes graphitization. That means the decomposition of iron carbide. So it promotes that particular reaction and formation of the graphite carbon. It promotes that reaction or the decomposition of the cementite. So because of which silicon is being considered. Whereas in addition to that, it's also sulfur and phosphorus is also been considered, which is of very less amount, that is less than 0.1 weight percentage. So these are the impurities that reduces the toughness of the material. And along with that, traces of manganese also can be observed, which is ranging from 0.5 to 1 percentage, which counteracts the sulfur's negative effects, that is reducing the toughness. So that can be taken care by this addition of this manganese. So we add manganese to counteract as a counteract measure for the sulfur's negative effects. And apart from this, the remaining whole material is iron. Then if you look at the microstructure, as you can see the microstructure, in this microstructure, this is a magnified image. So magnified image, and this is the microstructure, where you can see these flakes. So these are the flakes, these are graphite flakes. All these are graphite flakes. So graphite presents in the form of flakes, which are similar to our cornflakes. So these are graphite presents in the form of flakes, which has been normally surrounded by the alpha ferrite and cementite or the perlitic mixture. Perlite is, again, if you recall, it's a combination of alpha ferrite and the cementite. It's alternately a mixture of alpha ferrite and the cementite. So this graphite has been surrounded by this matrix, perlitic matrix or ferritic matrix. So cementite is the dark region that you see is the cementite, and the bright region that you can observe here, that could be your ferrite. And this is the area magnified image you can see, that is a matrix, perlitic matrix. Alternate layers of ferrite and cementite can be observed, and graphite here that is present in the form of flakes. So when you see the fracture surfaces of these gray cast iron, they appear in the gray color. That's why the name gray cast iron. So when you break or when you look at the fractured surface, it appears in the gray color. That's why the name is given as a gray cast iron. This gray appearance is coming from the graphite flakes, because of the carbon. So when the slow cooling is done during the heat treatment process, when the slow cooling is done, it leads to the formation of coarser flakes, which are weaker in its nature. And when you do the fast cooling, it produces the finer flakes, which are stronger in its nature. So your heat treatment, the heating rate, the cooling rate will decide the flakes and its the strength of overall material. If you look at the properties of grey cast iron, so mechanically, grey cast iron is comparatively weaker, and it's also brittle in its tension as a consequence of its microstructure. So if you look at the microstructure, what we have seen, there is a presence of graphite flakes. These graphite flakes are sharp and pointed. If you look at, so these are sharp and pointed. So these they will be serving as the points of stress concentration, especially when they are subjected to the tensile loading. And so the grey cast irons, the grey iron, is relatively weaker. It's comparatively weaker and brittle in nature, especially in the tensile loading, under tensile loading. Its strength and ductility is much higher in the compressive loading. However, the tensile loading it is weak, but compressive loading its strength is almost 3 to 4 times higher than the tensile strength, and it offers a good ductility also under compressive loading. They are very effective in the damping vibrational energy. So they offer excellent damping resistance. So it absorbs the energy that is produced by the mechanical vibrations. In addition to that, the grey irons also exhibits very high resistance to the wear because of high hardness of the material and the presence of iron carbide here. In the molten state, they will be giving good fluidity. They offer excellent flow characteristics, and that is very much needed for casting. So it offers excellent castability also, which permits basically because of this high fluidity, which permits casting pieces having intricate shapes. If you are having complex shapes, so these because of good flowing characteristics, these molten iron will be filling all the complex shapes, and so you will be getting intricate structures also are possible here, and it also having the very low shrinkage. So after casting, the final dimensions, if you compare it, so casting dimensions and the final dimensions, its shrinkage is very low, and that is very much required for manufacturing. Most importantly, grey cast irons are among the least expensive of all metallic materials. When you look at the metallic materials like your steels and cast irons, among all these, grey cast iron is the least expensive material. However, it also have certain limitations. So these limitations are, as we have discussed, it is having the low tensile strength and the ductility because of the flakes, which acts as stress concentration regions or crack initiators, and it is also having poor impact resistance because of its brittle fracture. Uh, brittle fracture. So because of its brittle fracture, it is offering very low impact resistance. These are certain limitations for this material. And if you see the applications of grey cast iron, it founds its applications in the automotive sector. If you look at, so it is considered for engine blocks, and the cylinder heads are being manufactured using this grey cast iron. And also brake drums for automobile vehicles are being manufactured out of these grey cast iron. In the machinery, most of the machine tool bases for the missions, any of the missions, CNC machine or lathe machines, milling machines. So the tool base is made out of this grey cast iron, and the pump housings also manufactured out of this grey cast iron because of their good damping characteristics. In the construction, manhole covers are being manufactured out of these grey cast iron. Then pipes, some of the pipes and decorative castings also manufactured out of these because of their less expensive among all the metallic materials. Then certain household applications also, cookwares also, we are using cast irons, cast iron pans. We are using it in South Indian region. They use it for making the dosa. on cast iron pans. So that is basically grey cast iron, and some of the griddles also manufactured out of these grey cast irons. If you summarize what we have discussed, graphite flakes will be defining the properties, especially the low tensile strength is due to the flakes, their pointed nature, sharp and pointed nature, which acts as a stress concentration regions, and also because their damping characteristics are mainly coming from the soft graphite material, which absorbs more energy, and its poor toughness is also a result of weak graphite flakes. So in short, graphite flakes in the microstructure in the cast irons that are deciding the properties for the gray cast iron. And this graphite flakes, the formation of graphite is promoted by the silicon, the addition of silicon, which promotes the graphite formation. And while the faster cooling that suppresses the formation of graphite formation, that is because the decomposition process is very limited, because in the fast cooling rates, decomposition is the time for decomposing is very short, and so the graphite formation is also uh, very limited. And because of that, even though the addition of silicon is there in the material, under the fast cooling rates, this graphitization is suppressed to certain extent, and they find their applications in the automotive and machinery components, especially due to their excellent castability and very good damping vibration characteristics. And it is not suitable for impact loading because of their brittle fracture nature. So in these lecture slides, contents have been taken. The content has been taken from these references, Callister and other textbooks. Then I'm throwing a question for pondering, and you may answer it in our chat link. So, why does grey cast iron fail in brittle manner despite having soft graphitic material? Soft graphite is present even though grey cast iron is brittle in nature. So, why does it? So, we have discussed it. From those, you can ponder on this question and you can provide your reply in the chat. So, with that, I'll conclude this topic, and we will see our next topic on ductile cast irons. Thank you.